Okay, year 9, and this is your first lesson, and question 1's quite difficult. Figure 1 shows a student walking on a carpet. The student becomes negatively charged because of the friction between her socks and the carpet. Explain why the friction causes the student to become charged. The whole idea here hinges around your understanding of an electron. I'm just going to go down the bottom of the paper here just to explain this to you. And an electron consists of a central positive charge, and it's surrounded, we think, by a cloud of electrons going around the outside like this. It's called like a shell. So it's minus on the outside, and these are electrons. And most atoms are balanced. They want to be balanced so that the plus and the minus cancel out. So this is the key word you have to be able to use in this question. Explain why the friction causes the student become charged. It's because electrons, so it's a key word going in, and they move from the carpet to the student. So this bit of the atom gets rubbed off and stuck onto the student's foot, and they end up with lots of negative electrons hanging around their foot. So the key point here then, electrons is 1 mark, and from the carpet to the student is your 2nd mark. On we go. The student's head is represented by the sphere in figure 2. The student is negatively charged, that's the previous bit. The arrow shows part of the electric field around the student's head. Draw 3 more arrows on figure 2 to complete the electrical field pattern. You have to use a ruler, boys. I say boys because it's often the boys that don't. And so it says 3 more, and you can put them wherever you like, but I'm going to put them evenly around like so. And you've got to put arrows on them, like so. And that's another very, very, very easy mark. You could guess that if you didn't know it, you could look at the first one and you could guess it. What they won't allow you to do is this sort of stupidity. That's not allowed. And lazy boys, and it is often the boys that do this, get the ruler and use a decent ruler. The negatively charged student touches a metal tap and receives an electric shock. Why? Okay, now if you put your fingers in the mains, you'll get an electric shock. Why? Because there's something called a potential difference between you and the mains. So we start this one with, there is a potential difference. And you need to know that term. And between what? Between the student and the tap. And that causes electrons to jump from the student to the tap. Used to happen a lot when you went shopping in Asda and they had carpeted floors, and you push a trolley on the carpet and you get a shock off the trolley. It's the same idea. The key point here, potential difference. This thing here is important, and you can see where the marks go. 1 mark for that. Between the student and the tap, that will be your 2nd mark. And then what's the result of that situation? Causes electrons to jump from the student to the tap. And it's that idea. It's also called earthing. The tap is connected to the ground. Electrons want to go to the ground. That's why you get lightning the way that you do. The next part of this, quite interesting. Some carpets have thin copper wires running through them. The student is less likely to receive an electric shock after walking on this type of carpet. Explain why. Well, copper is a conductor. That's worth a mark on its own. It therefore has a low resistance. Therefore, the electrons or the charge is carried away in the same way that electric wires will carry electrons when you're doing experiments in the lesson. That's the basic idea they want there. So the two things, copper is a conductor, it's got a very low resistance, so that's that thing gets you 1 mark, and what's going on, well, the electron's charge is carried away because the copper wire is in the carpet, so therefore you don't get a shock. And the next one's a nice one. Solar cells produce electricity using light from the sun. The symbol for a solar cell is that thing, and this householder has 3. Each solar cell has an output potential of 0.7 volts. So which arrangement of the 3 solar cells will give a potential difference of 2.1 volts? Well, 7 3s are 21. It's obvious, isn't it? They're going to be put together. Now they've got to go the right way round. That would work. That won't, because those two are back to front. That won't, because those two are back to front. It's the same as batteries. They must all go in the same direction, so you'd put a tick in that box. Easy mark. And then we come to the last part of this one, and we have a solar cell has a resistance of 2.5 ohms when the output potential difference is 0.7 volts. Calculate the current for the solar cell and use this equation. And the equation's given to you here, so therefore you're going to write down current equals potential difference is 0.7 divided by resistance 2.5. And if you divide that out, and he says, looking for his trusty calculator, so take my calculator and 0.7 divided by 2.5 equals 0.28. Now to the lazy boys again, they will want to see this. You're getting 2 marks this question, and I get slightly fed up when students don't put the working out. They want to see that. They don't want to see you just put numbers in there on your calculator like I've just done and then shove out the answer. They want to see the answer written down properly, so the answer's there, please. Be careful. And the next bit down shows an interesting graph. It's got current going down the side. It's got potential difference along there, and the current of the solar cell stays pretty constant. Potential difference going up, and then it suddenly drops off. Shortly after 0.6 it drops off. So with that in mind, because we're going to turn the page, the power output of the solar cell is calculated using the equation power is current times potential difference. Which value of potential difference on the graph above gives the maximum power output of the solar cell? And they give you 4 values. If you look at the back to the graph, 0.1 volt here gives 0.9. 0.3 volts, this is the current, 0.9. So clearly it's nothing to do with that bit there. And what you're looking at here, go back to that equation. Go back to that equation. If you look at the equation, what makes the current bigger? What makes the power bigger is if the potential difference is the biggest. Well, that works well up to 0.6. When you get to 0.7, because you could say, well, why is it not 0.7? Well, 0.7 on my graph has got a current of 0. So although you get a bigger one of those, that's naught. So it can only be this one. You get 0.6 there, and you'll get a slightly reduced current compared to the ones before it. It's about there, but it's still a good current there, 0.85. That will give you the greatest power. So you've got to give the reasoning for your answer there, and the reasoning you're going to come up with is that the 0.7 volts has 0 current, so power equals 0. The 0.6 volts gives the highest power reading. Okay, so that one would work well for you. And you can see where the marks have gone. There's 2 points. I've put down 2 very specific points. Right, part D. Write down the equation that links efficiency equal and total power input and total power output. And so efficiency equals output divided by input, or total power output divided by input. You have to know that. If you don't know it, you're going to have to guess it. And then finally, the last part is to put my numbers in. Calculate the useful power output of the solar cell. So put the numbers in first of all, even if you don't know what you're doing. Efficiency is 0.2, so that's that one. So 0.2 equals the output, I'm being asked to find that, divided by the input is 2.4 there. Now remember what I've said to you in many a lesson, the best way to deal with this, I think, is this idea. You have crossed arms going through the equal sign. I want to get the 2.4 away. It's got to go across the equal sign. It's down the bottom at the moment. It's here. If I put the numbers on here, it's 0.2 equals output divided by 2.4. It's got to go up. So what that means is I'm going to have 0.2 times 2.4 equals the output. And 0.2 times 2.4, you can get a calculator if you're not sure. 2.4 times 0.2 equals, and it's 0.48. Okay, and that will give you, I think that gives you the full marks. So that takes you to the end of that paper, and you should be quite happy with that. The thing about it I think was the hardest was the first bit. I think this bit with the socks on the carpet and the movement of electrons is the hardest bit. And if you understand this bit about the structure of the atom, it's easy. Hope that helps.